Alright, today we're going to do a short video on trusses. Before we can solve any truss problems, we have a couple of assumptions we have to make first. The first assumption we have to make are trusses are connected at only their ends. The second assumption is trusses are connected by frictionless pins. A third assumption is the truss structure are loaded only at the joints. And our last one is the weight of the truss members are negligible. The reasons we have these assumptions is it allows us to solve the problem. The next thing we have to worry about is making sure that our truss is statistically determinate, i.e. can we solve it? Now this equation to figure this out is the truss members is 2 times the joints minus the reaction force. If this statement is true, then we can solve the problem. This is the example that we'll be looking at today to help illustrate trusses. We have 3 triangles here. Each side length is 1 meter and each angle is 60 degrees. There are 7 members here. There are 5 joints and 3 action forces. So we have 7 members equals 2 times 5, which is 10, minus the 3 reaction forces is 7. So we have the 7 truss members is 7 on this side as well, which means we can solve our problem. What we've done here is we've put a pin joint here and a roller joint here. This allows 2 reaction forces on this side and 1 reaction force here. We also have a load of 1 kilonewtons coming off point C. The first thing we must do is draw a free body diagram in order to calculate our reaction forces, which are Fa of x, Fa of y, and Fe of y. First, we solve for f of x, the sum of forces in f of x, which will always be equal to 0. Because there is only one force in the x direction, Fa of x is 0. Next we have the sum of the moments around point A equals 0. So 0 is equal to this 1 kilonewton in the negative direction, going clockwise, and F of Ey 2 meters away going anti-clockwise, assuming positive is anti-clockwise. From this we can calculate the F of Ey is 0.5 kilonewtons in the positive y direction. Next we find the sum of the forces in the y direction. This is all going to be 0 again. So we have 0 is Fa of y plus Fe of y minus the 1 kilonewton load. This gives us Fa of y is 0.5 kilonewtons. Now we begin to solve the individual loads on each truss member. The way we do this is by calculating the loads at each joint. So first we're going to look at point A. At A we have truss member AB here, truss member AC here, and the force AY here of 0.5 kilonewtons. We do have a force in the x direction, but this is 0, so we do not need to write that down. Also, what we can do here is Fa of B has a component in the x direction as well as the y direction, as marked here and here. So this is very similar to what we did before with the free body diagram, is we now sum the forces in the y direction and they must equal 0. So we have our F of AB sine 60 degrees plus our F of AY must equal to 0. This gives us FAB is negative 0.5 over sine of 60 degrees, giving us negative 0.5774 kilonewtons. The negative in this answer means that the truss is under compression. Next, we find the sum of the forces in the x direction, which must also be 0. We have 0 is F of AB cos 60 plus the force in the AC truss. This gives us F of AC is equal to 0.5774 cos 60 degrees, which gives us an answer of 0.2887 kilonewtons. This is an example of how you can do it at each point. Once we've figured these out, we can use that to trace around through our truss and calculate the forces in each member. Now the three options we have with forces in member is if we have a negative, that means the beam is in compression, and the beam AB, the forces will be acting towards the center of the beam. If we have a positive load, then the same truss will be in tension, so we're being pulled outwards. And if we have a 0, that means the beam has no force, it's a no force truss and there's no force acting on it. Thank you for watching, I hope you've learned something.